I like it cold. Questions about your homework? We did most of it in class. You had time to finish most of it in class, especially with enrichment. That was easy. That was easy? Wow, okay. With the calculators too? Oh. So as I'm going through all that, y'all didn't ever tell me that y'all did that before? You never did it? Okay. Well, buckle up for today. It's a possibility. Always a possibility. Possibly. I told you we will have so many. They will stack up so fast that you will find they're nothing to you. I don't want you stressed about them like that because it's just a little check. Like I know we're gonna have to take all our spare time and focus on factoring now because a lot of you need the extra practice with factoring. After every test. So each unit I switch around. You can't see good. Do you pull up the Miro board on your computer? Okay. All right. Y'all ready, Freddy? You hadn't used your brain yet. Where are you breaking from? Well, for some of y'all, I think it was y'all were talking about sliding into stuff and. All right, let's talk about some radicals. I hope. Not yet. You need me to wait? Okay. Just we'll wait on Rhett. Let us know when you're ready, Rhett. Okay. You get ready? All right. Tell me what is a radical. Yes, you do. Yes, you do. In the yeah, that's right. Another word would be a square root. That's right. Now, explain to me what it means whenever I say take a square root. Like, explain to me what's going on here. What am somebody's never seen this. Explain what it means. It is the opposite of an exponent. Let me give you a little more to go on. What if I put a number under here? That's exactly right. I'm looking for what number times itself twice gives me what's under here. Do you agree with that? So in this case, we know that 2 times 2, and these numbers have to be exactly alike, right? I know that 2 times 2 is 4, so this could be 2. Is that the only thing it could be? What else could it be? It could be negative 2, because negative 2 times negative 2 is positive 4, and that's what's under there, and that's the definition y'all told me, right? Multiplied by itself twice gives you what's under there. So what I do as I take these radicals is I put a little plus or minus sign in front whenever I do take the root. I hope y'all have done that before. No? Okay. Yeah, okay. Well, if not, it's okay. Here we are. All right. That's the old stuff, all right? But you have to understand that to understand what we're going to do with the radicals. So let's talk about some perfect squares before we start. And let's just start. 1 squared would give me 1. So that means that the square root of 1 is plus or minus 1. Yes? Say yes, because that's right. Okay. All right. 2 squared would be what? 4. These are my perfect squares in this column here on the right. Give me another perfect square. 9. Give me another. Go in order, though. 16. 25. I'll tell you when to stop. 49. 64. 121, 144. That's probably good. It will probably help you as we go through this with what we're fixing to do, and you very well could have done this in your previous math. It is sticky hot. It will probably help you to have a list of these numbers written out on the side of your paper, especially if you struggle with what we're doing today. But this is what we're going to use, okay? Now, with that said, let's talk about, we have two properties of radicals that I want to talk about. And then we'll talk about why we're doing this. The first property is if you were multiplying under a radical, you can split it up to two different radicals multiplied together. Notice I said multiply. This does not work with addition subtraction. This only works here whenever I'm multiplying this way. Okay? Why is this helpful? Well, this is helpful because this is the property we're going to use to simplify radicals. So when I simplify radicals, we'll run you through some steps here. So maybe I have the square root of 112. A simplified radical means you cannot divide what's under there by any perfect squares, okay, evenly as a factor. Remember, we talked a lot about factors. So the first thing I want to do is I want to look for the biggest, if I say PS, you know what I'm talking about? Perfect square. The biggest perfect square to divide evenly. Have you guys done this before? All right, so look at this list. I'm talking about 112, so I'm going to probably start somewhere around maybe 64. Can I divide it by 64? No. Notice I said biggest, so that's why I'm starting biggest. Can I divide it by 49? 36? 25? 16? I don't know. Yes. 16 times what? 16 times 7. So would you agree that's the same thing? All I did was write 112 a different way. It's still 112. 16 times 7 is still 112. But I just wrote it a different way. I wrote it as a multiplication problem. Well, based on this property, I can split that up into two different radicals. So split it up. So this would be the square root of 16 and the square root of 7. Why is that handy? Well, 16 is a perfect square, right? What's the square root of 16? So I'm just going to simplify each radical now. 4 square root of 7. Check it again and make sure, is there anything I can divide 7 by evenly? Any perfect square that I can divide besides 1? 1 doesn't count. No. That's how I know I'm done. I throw a plus or minus. It always goes in the front, okay? If you put it after the 4, what's going to happen is it's going to look like an addition subtraction problem instead of the multiply problem that it is. So there's my simplified radical. Does that make sense? This operation here is multiplication still. So if there's already something out there, then I'm multiplying to that number out front. Okay, let's do another one. Try this one on your own and see what happens. I can't find it. Ooh, you got to go a little past the list on this one. Anybody find it? Not yet? 289. It's 289. 17 squared. So let me tell you what I did whenever I didn't mean to give you one so hard to start with for the very first example. When I looked at this, once I got to about 81 didn't work, I went, wait a second. And I divided it by 2 to see if I got a perfect square when I divided it by 2, because then that gave me the number. I just kind of went a little wonky with it. But yes, it's 289. So 289 and 2 are the two numbers that make up 578. Yes? Y'all okay with that? Now, the square root of 289 is what? 17. Okay, so I've got this 3 that sits out here, right? It's being multiplied. So I'm going to multiply it to 17, because that's the square root of 289. And then I've still got the square root of 2. Does that make sense? So that's 51 times the square root of 2, and the plus or minus goes in front. Does that make sense? Yeah, sure. Y'all saying uh-huh. Absolutely. How about, let's make it a little bit easier. That one. Give you a second. Different. Everybody did 9? 36. Okay, so let me show you how, even if you don't pull out the biggest one, right? Because I told you to go with the biggest one. Even if you don't pull out the biggest one, your all hope's not lost. You can still get back to the right answer. So I'm going to do it both ways and show you what happens here. I'm going to start with the 36. 36 times what? 2, right? So 5 times the square root of 36 times the square root of 2, which is 5 times 6 times the square root of 2. So I've got 30 root 2. Yes? What happens, though, if I'd have picked 9 instead of picking 36? So I've got 9 times what? 8. Well, the square root of 9 is 3. So you're exactly right. Now I'm in this situation where I can divide this by another perfect square. Remember I said, look at that radical. Can you divide it by a perfect square again? That's how you know you're done, is when you can't. But here, I can divide it again, right? I've got an 8, and 4 goes into 8, so I could have 4 and 2. Square root of 4 is 2. What's 15 times 2? 30. It's more, that's exactly right. That's why I said pick the biggest, but it's not wrong if you don't pick the biggest. You can keep going. It's more work. Tell me what you think about simplifying a radical just this way right now. Can y'all do that? Okay. That is rule number 1. And I'm showing you these 2 rules because then we're going to use those 2 rules to solve quadratics. Remember, that's the goal. Remember, I told you every lesson we do from here on out in this unit is about solving quadratics. Okay? So I'm showing you all the background stuff. The solving part's easy. All right. Rule number 2. If I am dividing under a radical, I can also split it up. But here's the problem. If this is a perfect square, that's wonderful. But I can't leave a radical in the bottom of a fraction. Have y'all ever heard that before? I have to do what's called rationalize, which is a big fancy word for just means get the radical out of the bottom. Okay? So when you end up in that scenario, say again? You absolutely do. So what I would have to do is multiply the top and the bottom by the radical that's in the bottom. Okay? And here's why. I want you to think about this for just a second. If I have the square root of b times the square root of b, remember how I could split them up into two different radicals? Well, why can't I put them back together under the same radical? I'm multiplying, right? That is by definition what a square root is, right? What would that give you? B squared. But what's the square root of b squared? B. It's just b. Anytime you have something multiplied by itself like that, it just leaves you with whatever. So here I've got the square root of a times b, right? But on the bottom, I just have b. And that's a real lengthy, long way to get to a very easy concept, but I wanted you to see why it was. So let me show you what I mean by this. Simplify that radical. What'd you do first? Split them up, right? Now the problem is that neither one of those are perfect squares, right? And always check to see if you can simplify it. And by simplify it, can you split it up like we did in the first example? Can't do that here with 5 or 2. So now I got to get rid of that radical in the bottom. How am I going to do that? Multiply it by what? Square root of 2. And if I do it in the bottom, I have to also do it in the top. Now I'm ready to clean my fraction up a little bit. Square root of 5 times square root of 2 is what? Square root of 10. Have it on the bottom. 2. Can I simplify that to the square root of 5? Ooh, I stumped you a little bit. No, I can't do that because they both have to be under the radical. Okay, so make sure you don't do that. I see a lot of students doing that all the time, but make sure they're both under the radical if you combine them. Okay, now if I started out like this, right, even though neither one of those could simplify, because they're both under the radical, I could do this now. And that's handy because it does simplify to 5. So that's the difference there. See how they were both under the radical here? And so I could combine them and simplify them. But if they're not both under a radical, you can't combine them. Does that make sense? Okay. Why in the world do we need to do this? Because we are getting ready to solve what? Quadratics. That's what we're doing this whole unit. Tell me how we've solved them so far. Give me one way. Graph and solve. That's right. What's another way? Factor and solve, right? Here's a third way. We're going to solve using radicals, okay? This is one of those things that it doesn't always work. You know how everything can't be factored? Everything you can't use a square root. So I'm going to show you how to recognize when to use it and then what to do. Y'all okay? I'm almost done. Yes, Miss McGee with her nose. Terrible. All right. When do I use this? if you're solving an equation, a quadratic equation, and x is only written once, that's how you know to use this method. What do I mean by that? If it looks like this, do you see how x is only in there one time? It's still a quadratic because I got x squared, but it's only there once. You see what I mean by that? It's not something x squared plus something x. The something x is missing. There's only powers of 2. That's how I know I can use this method, okay? Now, when I solve an equation, go back to whenever you were solving linear equations. Because what I'm going to do here, if I say isolate, do you know what that means? Get it by itself. I'm going to say isolate x squared. In other words, get the x squared by itself. When you were solving regular linear equations, how did you know the order in which to solve them? In other words, how do I know what to do first here to get x squared by itself? And you may not have had a teacher teach you this way. I don't know. What do you do first to get x squared by itself? Why? Why do you subtract? Why do you get rid of the 5 before you get rid of the 81? It does have the x, but what makes you get rid of? Okay, yes, that's a good way to look at it. Any other thoughts? I guess what I'm getting at is if there's multiple steps to solve, did any teacher ever explain to you how you know which step to do first and then where to go from there? I'm going to go no. Probably. Probably you just don't remember. All right. When we simplify things, how do we know the order in which we simplify? PEMDAS, right? We go order of operations, yes? Would you agree that solving is undoing that? Solving is undoing everything because we're getting x by itself. When we solve, we go backwards PEMDAS and we FADMAP. Parentheses are going to be dead last, then exponents. So the first thing I want to take care of is addition or subtraction outside of any parentheses. Okay, that's why I move it first. And I say that because whenever we get to equations that are a little bit harder than just a linear, if you understand the order that you go in, it'll make it a little bit easier for you. All right, so y'all said move the 5, right? You'll hear me say a lot, tab map your way out of it, and this is what I mean. So if you hear me say that, that's all I mean is solve it for x the way you would a linear equation. All right, so I move the 5 because that's my addition subtraction. Then I have 81x squared equals, what is that, 16? Well, that'll work this time, but let's solve it for x first, and then but you are right, just because they're both perfect squares. But if I'm trying to get x squared by itself, what can I do next? Divide it by 81. I know y'all hate fractions, but fractions are your friends. If you will leave it as a fraction, it will be a lot easier than if you don't. At this point, we could because it's a perfect square, but I wanted to show you a way that I like to show you methods that always work as opposed to only work under certain situations. So if that had been a 7 in front of that x squared, that wouldn't work. All right. If you see it that way and want to do that, though, that's fine for one if you recognize them both. I think that's what Rhett was saying also. All right. Now I want to get rid of the squared, and several of you have already jumped ahead and you said you see what, and I'm sorry if this, I know that this bores some of y'all. Some of y'all, y'all must have had different teachers or something, because some of y'all are like insanely bored because you've done this before, and others of you, I can tell you don't quite get, so bear with me. We will get the stuff that nobody's seen really soon. All right. To get rid of this, because remember I'm solving for x, that's the goal. Yes? How do I get rid of an exponent of 2? Square root. This and this are always opposite operations, and they always cancel each other out. Okay, so I want to eliminate. I'll put the little 2 here. I'm going to say with a radical. That way we know that's what we're doing, right? So I have this x squared equals 16 over 81. If I take the square root on both sides, yes, this is eliminated, and it leaves me with x equals, well, now I've got myself in this fraction situation, but lucky for me, both of those values are perfect squares, yes? So I'm not going to have to rationalize any denominator. What's the square root of 16? What's the square root of 81? But this is a plus or minus situation. Does that make sense? Let's relate it back to graphing. What does this mean about the graph of this parabola? It's zeros, which are zeros are another word for what? Roots, which are another word for solutions. Give me one more word. X-intercepts. It's crossing the x-axis where? Plus or minus 4/9, at 4/9 and negative 4/9. Does it make sense to you as to why we're getting 2 answers instead of 1 answer? Right? Remember that parabola, and it's crossing both places. That's why we get 2 answers. That's why you'll get so mad at me on this quiz, but if you just put 4/9, I'm only giving you half credit because you only gave me one of the answers. You'll only do it one time, and you won't do it again. Okay? See why it's important we need both of them? There's 2 answers there. You okay? Yeah. That's fine. Let's do another one. Solve it for x and make sure your answer is fully simplified. I think the hardest part about these is simplifying the radicals. That's why I took so much time in the beginning, but y'all might think otherwise. I don't know. Is it about the fraction that's in there? You forgot what. So instead of dividing by a fraction, what can you always do? Multiply by the reciprocal. I never want to divide by a fraction. I want to multiply by the flip of it. So let me walk you. Yes, negative 2 over 1. Yep. Multiplied. Yeah, right. So as I subtract 1, I've got negative 1/2 x squared equals negative 40. To eliminate this, you probably did this to start with, right? And that's messy, and you go, oh my gosh, what in the world? Instead of doing that, don't ever divide by a fraction. Rather, multiply by its reciprocal, which just means flip it over and multiply. And when we multiply fractions, and this happens to be 2 over 1, which is just a whole number anyway, remember, if you do multiply fractions, it's top times top, bottom times bottom. Easy to multiply fractions. This cancels, and I end up with x squared equals 80. Now what? Rhett says 16 is the biggest perfect square, so everybody agree? 16 and what? 16 and 5, which means it's 4 root 5, and don't forget your plus or minus, because without that, you only have half the answer. Does that make sense? That does matter, actually, because then you'll have the wrong one under the radical. Oh, you're talking about, do you mean like this? Or do you mean like this? Yeah, do that. All right, I got your homework coming around to you. If you got this, I don't want you to be bored out of your gourd. You can go ahead and start on your homework. But I'm going to work a couple more examples for those who need a couple more examples. And I'll keep working until you tell me you're good. Yes. Yeah. Let me do a couple more examples, not on the homework, so you have something to practice with, and then I'll move to the homework ones that I work with. Rhett hadn't passed them. All right. Let's see. Try this one. Yeah, you should get a word. I'm not with you. All right. Not doing it. That is not what it said. He said your hair looks nice today. Mm-hmm. He said he wished his hair could look like that. He said your boots are nice too. Why? They're not. They're the wrong color. Oh. You got the wrong ones for Christmas. Anybody get it yet? Y'all still working? Okay. Absolutely. Yep. All right, y'all get x squared equals 60? Yes. And then we square root it. What's the perfect square you divided 60 by? 15? No. What's the biggest one? Yeah, 4. 4 and 15. So plus or minus 2 root 15? Is that what y'all got? Need another or nah? Okay. As you work through your